To understand how VDB works, let's break it down to its fundamentals. Imagine a cube with sides 1 centimeter long. Now that we have this cube, we can store some information inside it. The type of data it holds can vary. For example, it could represent color. Let's say 0 means no color and 1 means white. Between 0 and 1, we can have all the in-between values. These represent shades or gradients of color. Using the same logic, we can add another data channel, such as density. In this case, white could represent maximum density and no color could represent zero density. Density then becomes a new type of data stored in the cube. From now on, we'll call this structure a voxel, short for volume pixel. So far, so good. But a single voxel doesn't tell us much. Let's duplicate it to form a 3-dimensional grid. Now we have a large box filled with voxels, each holding color and density information. This gives us a basic volumetric object, in other words, a cloud. When simulating volumetric effects such as smoke or clouds, each voxel can also store vector data. This allows information to move and change throughout the grid, which ultimately creates a realistic cloud simulation, from theory to practice. Let's load a VDB cloud into an empty scene. When you click once in the scene, the V-Ray volume grid will prompt you to load a VDB file. I'll use one of the cloud assets from the Pixel Lab website. Each asset includes 4 VDB files representing different levels of detail, LOD. Once the VDB is loaded, you'll need to choose a render preset and select the software the asset was created in. In this case, I'll choose Houdini. In the viewport, you'll see a proxy representation of the cloud. As mentioned, Pixel Lab provides 4 LOD versions. The file ending in 0.2 is the highest resolution grid containing the most detail. If you open the Frame Info tab, you'll see how many cells, or voxels, each version contains. The more voxels, the higher the level of detail. Let's scale the cloud up by 100 times and enable GPU shaded preview to make it appear more cloud-like. I'll also turn off the bounding box for a cleaner look. In the detail reduction section, you can disable auto reduction and set the value to 0. This allows you to see every voxel in the viewport. However, be cautious. Displaying full detail may cause lag or freezing. Now let's move on to the Rendering tab. Open the Volumetric Options section. Under Smoke Opacity, you'll find access to the Density channel. Adjusting the opacity will increase or decrease the visibility of the density data. The Smoke Color option lets you change the color of the color channel to any tone you like. This gives you artistic control without needing to re-simulate the cloud. Next, change the Based On setting to Smoke. This allows you to control opacity directly using the diagram. Finally, let's use Smoke as the source for color. Here, you can map a color gradient based on the density values across the grid. Now you know the essentials of VDB and how to load in your scene. Thank you.